Right now, as you sit there watching this screen, you likely feel perfectly still, safe, and anchored to the ground beneath your feet. But that feeling of safety is a biological illusion designed to keep you sane while you hurtle through a violent void at impossible speeds. At this very second, the Earth is spinning on its axis at 1,000 miles per hour, dizzying speeds that would kill you instantly if the atmosphere vanished. Simultaneously, our entire world is orbiting the Sun at 67,000 miles per hour, a bullet firing endlessly through the dark. But even that terrifying speed is nothing compared to the true velocity we are currently experiencing as cosmic hostages of gravity. Our entire solar system, along with the billions of stars in the Milky Way, is being dragged across the universe by an invisible hand. We are moving at over 1 million miles per hour towards a specific point in the deep southern sky that astronomers call the zone of avoidance. For decades, scientists were terrified because they could measure the speed, but they could not see what was pulling us. Something massive, something with the gravitational weight of a quadrillion suns, is waiting for us in the darkness beyond the dust clouds. This is not a science fiction story about a black hole. This is the reality of the Great Attractor, the gravitational monster in our backyard. Every atom in your body is currently rushing towards this gravitational anomaly, and nothing human technology creates can ever stop the slide. To understand the danger, you must first understand the scale of the trap that the universe has set for our galaxy. We live in a structure called the Laniakea supercluster, a glowing web of 100,000 galaxies bound together by gravity. Laniakea translates to immeasurable heaven, but a more accurate name might be the immeasurable cage for everything inside it. All these galaxies are flowing like water down a drain, heading towards a central point of density that defies the laws of chance. When astronomers first pointed their radio telescopes at this region in the 1970s, the signal they received was confusing and chaotic. The center of this gravitational pull lies hidden behind the thick dust lanes of our own Milky Way galaxy, blocking visible light. This obstruction creates a blind spot in our sky, a region where we cannot see the monster that is slowly eating our horizon. Imagine driving a car at top speed towards a concrete wall, but your windshield is painted black so you cannot see the impact coming. That is the existential horror of the zone of avoidance. We know it is there, we feel its gravity, but we cannot watch it approach. Recent X-ray astronomy has finally allowed us to peer through the dust and catch a glimpse of what lies in the heart of the danger zone. What we found was a cluster of galaxies so dense and massive that it warps the fabric of space-time around it like a heavy stone on a trampoline. This is the Norma cluster, a region where thousands of galaxies are being smashed together in a chaotic, violent ballet of destruction. But as we gathered more data, the horror deepened, because the math for the Great Attractor still did not add up. The Norma cluster is massive, but it is not heavy enough to account for the sheer speed at which we are being dragged towards it. There is something else behind it, something even larger, pulling the Norma cluster and us along with it into the abyss. We call this larger horror the Shapley supercluster, the most massive concentration of matter in the local universe, a true leviathan. It contains more than 8,000 galaxies, all bound together in a gravitational knot that dominates our corner of the cosmos. But even the Shapley supercluster might not be the end of the line, as new theories suggest a flow towards something even more distant. While we worry about asteroid impacts or solar flares, the entire galaxy is engaged in a suicide pact with this distant gravitational anomaly. The most dangerous place in space isn't a single planet or a star. It is the destination of this cosmic river we are floating in. If humanity survives for billions of years, we will eventually find ourselves merged into this hyperdense region of old, dead stars. But there is a theory that suggests the danger is not just about gravity, but about the stability of the universe itself in that region. Some physicists speculate that regions of extreme mass could trigger a collapse in the vacuum state of the universe, a bubble of total erasure. This concept is known as vacuum decay, a bubble of true nothingness that expands at the speed of light and deletes physics as it travels. If the Great Attractor is a point of instability, we wouldn't see the death coming. We would simply cease to exist in an instant. The light from the event would hit us at the exact same moment as the destruction, leaving no time for fear or goodbye. This is the reality of living in a dynamic, violent universe, where safety is merely a temporary pause in the chaos. We look up at the moon and feel peace, ignoring the fact that space is a hostile environment trying to kill us every second. To understand the most dangerous place, we have to look at what happens when matter is compressed beyond the point of no return. The environment near these superclusters is bathed in high-energy radiation that would sterilize an Earth-like planet in a matter of days. Intergalactic space is not empty. It is filled with hot gas radiating at millions of degrees, a scorching wind between the galaxies. Any civilization unfortunate enough to evolve near the center of the Great Attractor would look up at a sky burning with X-rays. They would not see a starry night. They would see a blinding fog of radiation that prevents any view of the outside universe. We are lucky to be in the suburbs of the Laniakea supercluster, far away from the crowded, violent downtown district of the cosmos. But our luck is running out on a cosmic timescale, as gravity ruthlessly reels us in towards the center of the web. Every second that passes, the distance closes by hundreds of kilometers. A slow-motion collision that was determined at the Big Bang. The most dangerous place in space is not a location you can avoid. It is a destination that is actively hunting you down. So when you look at the night sky, remember that the stars are not just lights. They are fellow travelers falling into the same pit. Now, let us strip away the comfort of the ordinary and investigate exactly what waits for us at the end of the universe. To understand the crime scene, we must first look at the oldest evidence in existence, the cosmic microwave background radiation, or CMB. This is the afterglow of the Big Bang, a faint hiss of microwave radiation that permeates every cubic centimeter of the visible universe. In a perfectly static universe, this background radiation should be completely uniform, possessing the exact same temperature of 2.725 Kelvin in every single direction we look. However, when astronomers analyzed the data with extreme precision, they found a terrifying discrepancy that shattered the model of a stationary Earth. One side of the sky is slightly warmer than the average, appearing bluer in the data visualizations, while the exact opposite side of the sky is slightly cooler, appearing redder. This is not a thermal fluctuation of the universe itself. It is a Doppler shift caused by our own rapid motion. We are plowing through the primordial fire of the Big Bang at an incomprehensible speed, creating a bow shock of energy in front of us and leaving a wake behind us. The universe is not sitting still, and neither are we. We are running away from something, or perhaps running towards it. This phenomenon is known as the cosmic microwave background dipole, and it provides the absolute reference frame for our motion through the cosmos. By measuring the intensity of this blue shift, astronomers calculated that our entire local group of galaxies is moving at approximately 600 kilometers per second relative to the cosmic background. That is 1.3 million miles per hour, a velocity that cannot be explained solely by the gravitational tug of the objects we can see. If you add up the mass of the Sun, the nearby stars, and even the Andromeda galaxy, the numbers simply do not balance the equation. There is not enough visible matter in our vicinity to generate the gravitational acceleration required to reach these speeds. It is as if we are a small boat caught in a raging current, moving faster than our engine should allow. The investigative question became urgent. What massive object has enough gravity to drag our entire galactic neighborhood across the universe at such a breakneck pace? The missing mass wasn't just a rounding error. It was a ghostly leviathan hiding in the data. In the late 1970s and early 1980s, a group of astronomers known as the Seven Samurai, including David Burstein, Sandra Faber, and others, began a systematic survey of elliptical galaxies to map the flow of the local universe. They weren't just looking at where galaxies were, they were looking at how they moved, isolating their, quote, peculiar velocity. In cosmology, peculiar velocity is the speed of an object after you subtract the expansion of the universe. The Hubble flow dictates that everything should be moving away from everything else. But the Seven Samurai found that the galaxies in our region were breaking this rule. They were all streaming together, like a school of fish responding to a predator, towards a specific point in the sky. This collective motion was a direct violation of the isotropic principle if there wasn't a massive attractor causing it. The discovery was disturbing because it implied a concentration of mass so large that it broke the homogeneity of the universe on a scale we hadn't thought possible. We weren't drifting aimlessly. We were being reeled in. The investigation hit a literal wall when the astronomers tried to pinpoint the destination of this galactic river. By tracing the vectors of velocity, all the lines converged on a specific region in the southern sky, located between the constellations of Centaurus and Hydra. But when optical telescopes pointed at this coordinate, they saw nothing but darkness. This wasn't because the region was empty. It was because our view was blocked by the most inconvenient obstacle imaginable: our own galaxy. The destination of the Great Attractor lies directly behind the zone of avoidance, the dense plain of the Milky Way, where thick clouds of interstellar dust and gas absorb visible light. It is a cosmic irony of the highest order. The most significant gravitational feature in our local universe, the thing that dictates our path through the cosmos, is hidden from us by the floorboards of our own home. We are speeding towards a wall we cannot see, blindfolded by the stars that give us life. The zone of avoidance covers about 20% of the night sky, creating a massive blind spot in our map of the heavens. For decades, this region was a blank space on the charts, labeled terra incognita by frustrated astronomers. Visible light simply cannot penetrate the layers of dust. A photon traveling from the Great Attractor has to navigate through light years of debris, and almost none of them make it to our telescopes. This created a sense of unease in the scientific community. We knew, based on the undeniable math of our velocity, that a monster lived in that darkness. We could feel its gravity pulling at the atoms in our bodies, but we couldn't verify its shape, its size, or its nature. It was a ghost story written in gravity, a presence that could only be inferred by the way it disturbed the peace of the galaxies around it. The silence from that part of the sky was louder than any signal we had ever received. To peer through the zone of avoidance, humanity had to upgrade its vision beyond the limited spectrum of visible light. We had to switch to radio waves and X-rays, wavelengths that can slice through the dust of the Milky Way like a knife through smoke. In the late 1990s and early 2000s, surveys like the Clusters in the Zone of Avoidance (CIZA) project began to peel back the curtain. What they revealed was a chaotic, overcrowded region of space that looked like a cosmic pileup. The dust cleared to reveal the Norma Cluster, a massive swarm of galaxies located about 200 million light-years away. At first, the investigative team breathed a sigh of relief. They thought they had found the culprit. The Norma Cluster was dense, heavy, and right where the math said the Great Attractor should be. It seemed like the mystery was solved, and the monster had been identified. But as they crunched the numbers, the dread returned. The Norma Cluster was big, yes, but it wasn't big enough. The math was stubborn and terrifying. To account for the peculiar velocity of the Milky Way and our neighbors, that 600 kilometers per second drag, the Great Attractor needed to have the mass of tens of quadrillions of suns. The Norma Cluster, while impressive, only accounted for a fraction of that gravitational pull. It was as if we had found a single boulder when we were looking for a mountain range. This meant that the Norma Cluster wasn't the destination. It was just a landmark on the road to something even larger. The investigation had to go deeper, peering past the Norma Cluster, further into the obscure depths of the Zone of Avoidance. It became clear that the Great Attractor wasn't a single object, but a region, a valley of gravity that stretched deeper into the universe than we had dared to imagine. We were not falling toward a single star system. We were falling into a bottomless well of matter that extended for hundreds of millions of light-years. Behind the Norma Cluster, lurking at a distance of 650 million light-years, lies the true leviathan of our local universe, the Shapley supercluster. This is the most massive concentration of galaxies in the nearby cosmos, a structure so immense that it bends the imagination. The Shapley supercluster contains more than 8,000 individual galaxies, packing a mass of more than 10 million billion suns into a relatively small volume of space. This discovery shifted the paradigm entirely. We realized that the Great Attractor was essentially a gravitational focal point, but the Shapley supercluster was the heavy weight behind it, the anchor that was sinking the fabric of space-time. The Milky Way, Andromeda, and the Norma Cluster are all being reeled in by this colossal structure. We are small fish being pulled by a current that flows into a massive ocean, and Shapley is the abyss at the center of that ocean. The implications of being part of such a massive flow are existential in nature. In the standard model of the universe, the expansion of space, dark energy, is pushing galaxies apart. Over time, the universe should be getting lonelier, with galaxies fading from each other's view. But in our specific corner of reality, gravity is winning the war against expansion. We are collapsing. The Laniakea supercluster, which we are a part of, is not expanding. It is contracting, densifying, and flowing inward. This means that while the rest of the universe might face a big freeze or heat death where everything drifts apart, our local future is one of collision and merger. We are heading for a big crunch on a local scale, a slow-motion car crash of galaxies that will result in a single, hypermassive elliptical galaxy trillions of years from now. We are condensing into a single point of failure in the dark. But the mystery of our motion involves a second player, a force that is not pulling us but pushing us. In 2017, a team of researchers mapped the flow of galaxies with unprecedented detail and found something that should not exist. A void so empty that it acts as a repulsive force. They named it the dipole repeller. Gravity is an attractive force, so technically, a void cannot push. But because the void is so devoid of matter, the gravitational tug from the dense regions like Shapley becomes unopposed. It creates a relative effect that looks and acts like a repulsive force. Imagine standing on a hillside. You aren't just being pulled down by the valley, you are being pushed away by the peak. We are caught between a monster and a ghost, dragged by the Shapley supercluster and repelled by the dipole repeller. We are being squeezed through the cosmos by the geometry of emptiness and mass. The dipole repeller is a region of space that is terrifyingly barren. While the average universe has a sparse distribution of atoms, this void is almost a perfect vacuum, stripped of galaxies, stars, and gas. It sits in the exact opposite direction of the Shapley supercluster, creating a perfect dipole flow field. The discovery of this repeller solved the math that had plagued astronomers for 40 years. The great attractor's pull wasn't enough on its own, but when combined with the push from the void, the velocity of 600 kilometers per second finally made sense. We are effectively sliding down a gravitational hill, running away from the empty wasteland of the repeller and tumbling towards the crowded city of the Shapley supercluster. It is a reminder that in space, nothing is a force to be reckoned with. The absence of matter is just as influential as the presence of it. This push-pull dynamic creates a basin of attraction, a concept that redefines our address in the universe. We used to think of our address as Earth, Solar System, Milky Way, Virgo cluster. But now we know those are just street names. Our true city is Laniakea, a supercluster defined not by its shape, but by its flow. The boundary of Laniakea is the edge of the watershed. On one side, galaxies flow toward the Great Attractor, and on the other side, they flow away toward the Perseus-Pisces supercluster. We are trapped inside this gravitational watershed, and there is no escape velocity that can get us out. We are bound to this cluster forever. If humanity ever develops intergalactic travel, we will find that the universe is partitioned into these islands of gravity, separated by expanding voids that are becoming harder and harder to cross. We are locked in the cage of Laniakea, and the walls are getting higher every second. Let us zoom in on the attractor itself and the conditions that exist there. If you were an observer located within the Norma cluster, your night sky would look nothing like ours. The density of galaxies there is so high that collisions are commonplace. In our part of space, galaxy collisions are rare events that happen over billions of years. In the heart of the Great Attractor, they are a daily reality. The space between galaxies is filled with the debris of these crashes, streams of stripped stars, orphaned planets flung from their orbits, and vast clouds of superheated gas. It is a cosmic scrapyard where the orderly spirals of galaxies are torn apart and mashed into amorphous blobs of elliptical giants. Life in such a region would be perilous. The stability we enjoy here in the quiet suburbs of the Milky Way is a luxury that does not exist in the downtown district of the universe. The intracluster medium, or ICM, in these dense regions is a lethal environment in its own right. It consists of plasma heated to millions of degrees Kelvin, emitting powerful X-rays. Here on Earth, we are protected by our atmosphere and the magnetic field of the sun, and we are far away from any major sources of X-ray radiation. But a planet orbiting a star inside the core of the Shapley supercluster would be bathed in a constant, high-energy glow. This background radiation could strip away ozone layers, mutate DNA, and sterilize the surface of worlds before life even has a chance to begin. The Great Attractor is not just a gravitational trap, it is a radiation hazard zone. The fact that we are moving towards it sounds terrifying, but we must remember the scales of time involved. We will not arrive for billions of years, but the destination is already fixed. There is a darker theory, however, known as dark flow, which suggests that the motion doesn't stop at the Shapley supercluster. In 2008, a team led by Alexander Kashlinsky found evidence that galaxy clusters are streaming towards a point even further away, potentially outside the visible universe entirely. This motion cannot be explained by the distribution of matter within the observable horizon. It implies that there is something massive lying beyond the edge of what we can see, structures that were pushed out of view by the rapid expansion of inflation in the early universe. If dark flow is real, it means our entire observable universe is just a small patch of a much larger tilting fabric, sliding towards a behemoth that we will never be able to see, measure, or understand. It brings back the ancient fear of the unknown, the monsters on the edge of the map. The concept of the observable universe is a hard limit on human knowledge. Since the universe is about 13.8 billion years old, we can only see light that has traveled for that amount of time. But space has expanded, so the edge is now about 46 billion light-years away. If the source of the dark flow lies at 50 billion light-years, it creates a causal disconnection. We are feeling the gravity of a ghost we can never contact. It is physically impossible for information to travel from there to here, yet the gravitational influence seems to persist. This challenges the standard model of cosmology, suggesting that the universe is not uniform on the grandest scales. It suggests that here is different from there, and that we might be living in a particularly tilted, sliding section of the multiverse. We are drifting in a current that originates in the unknowable. Let's bring this back to the physical reality of the zone of avoidance. The dust that hides the Great Attractor is not just annoyance, it is the material of creation. It is composed of silicates, carbon, and ice, the same stuff that makes up the Earth and your body. This dust is the ash of dead stars. The reason we can't see the Great Attractor is that we are looking through the graveyard of billions of ancestors. The plane of the Milky Way is a thick disk of this stellar soot. It is poetic in a melancholic way. The dead stars of our own galaxy are shielding us from seeing the monster that is eating our future. We are hiding behind the corpses of suns to avoid looking at the end of the world. While we obsess over the Great Attractor, we often ignore the local threats that are part of this flow. The collision with the Andromeda Galaxy is a direct result of this local gravity well. Andromeda is heading straight for us at 110 kilometers per second. In about 4.5 billion years, the sky will change forever. The Milky Way and Andromeda will pass through each other, their supermassive black holes engaging in a death spiral. The chaotic gravitational tides will fling stars out of their orbits, sending some into the void of intergalactic space to freeze, and plunging others into the maw of the central black holes. This event, forming the future galaxy Milkomeda, is the first step in our consolidation into the Laniakea superstructure. The Great Attractor is the long game, but Andromeda is the immediate threat in the gravitational war. Computer simulations of the Laniakea supercluster resemble a neural network, a brain. The filaments of galaxies look like neurons, and the clusters look like synapses. This visual similarity has led to some wild philosophical speculation, but physically, it represents the path of least resistance for gravity. Matter flows along these filaments. We are currently in a filament, a strand of the web, sliding down the thread towards the knot. Being in a filament is relatively safe. It's the rural area of the cosmos. But as we slide down, the density increases. The environment becomes more hostile. We are moving from the quiet countryside of the cosmos into the roaring industrial furnace of the cluster cores. It is a one-way migration that every galaxy in our group is forced to undertake. The sheer scale of these structures makes human existence feel absurdly small. The Laniakea supercluster spans 520 million light-years. To cross it at the speed of light would take 500 million years. And yet, it is just one of millions of superclusters in the visible universe. The Perseus-Pisces supercluster, the Coma supercluster, the Hercules supercluster. They are all titanic monsters in the dark, fighting a tug-of-war with gravity. The most dangerous place is a relative term. To a bacteria, a drop of water is a universe. To us, the solar system is home. But to the universe, Laniakea is just a small ripple in a vast, expanding ocean. The terror comes from realizing that the ripple is collapsing, and we are trapped inside it. Why does this matter to you, a primate living on a rock for 80 years? Because it defines the limits of your potential. If humanity survives, if we become a Type 3 civilization, we will eventually hit the walls of Laniakea. We will realize that we cannot leave. The accelerating expansion of the universe is pushing the other superclusters away from us faster than light. The Great Attractor and the Shapley supercluster are effectively our eternal prison mates. Everything else will fade from view, redshifted into invisibility. In the far future, the sky will be empty except for the galaxies within our own supercluster. We are being isolated. The universe is breaking up into lonely islands, and we are drifting on our specific raft towards a waterfall. The silence of the universe, the Fermi paradox, might be linked to these gravitational hazards. Perhaps civilizations that evolve in the dense, dangerous regions of the Great Attractor are wiped out by frequent supernovae, gamma-ray bursts, and gravitational disruptions before they can transmit a radio signal. It is possible that the safe zone for life is a very narrow band in the low-density filaments far away from the attractors. We might be alone simply because everyone else lived in the bad neighborhoods of the cosmos and didn't survive the environment. Our isolation is our safety, but our motion is slowly destroying that isolation. We are drifting from the safe zone into the danger zone, carrying our fragile biology into a realm of high-energy physics. Astronomers use the term redshift to describe objects moving away, and blue shift for objects moving closer. The Great Attractor is the king of the blue shift. It represents the contraction of our world. While the philosophy of the 20th century was dominated by the idea of an expanding, cooling universe, the reality of the 21st century data is that our local experience is one of contraction and heating. We are not freezing alone. We are burning together. The big crunch may not happen for the whole universe, but it will happen for us. All the galaxies in Laniakea will eventually merge. It is a destiny written in the gravitational constants of nature. But what if the Great Attractor is hiding something even more exotic? Some theoretical physicists have proposed that superdense regions could be the nucleation points for vacuum decay, as mentioned earlier. If the Higgs field is metastable, it only takes a sufficient concentration of energy to tip it over the edge. A region like the Shapley supercluster, with its extreme mass and energy density, acts as a stress test for the laws of physics. If the fabric of spacetime is going to tear, it will tear there first. We are moving towards the testing ground. We are the crash test dummies in a vehicle driven by gravity, speeding towards a wall to see if the airbags work. The data from the James Webb Space Telescope is beginning to refine these maps even further. It is peering through the dust with infrared vision, finding more galaxies, more mass, and more complexity in the zone of avoidance. Every new data point confirms the old fear. There is more matter there than we thought. The universe is heavier than it looks. This dark matter that binds the clusters together is the invisible scaffolding of our reality. And the Great Attractor is one of its densest knots. We are not just falling into a pile of stars. We are falling into a pit of dark matter, a substance we cannot see, touch, or understand, yet it dictates every move we make. The structure of the Great Wall, the Boss Great Wall, the Sloan Great Wall, these are massive filaments of galaxies that wall off sections of the universe. The Great Attractor is a junction point between these walls. It is a cosmic intersection. The traffic there is lethal. When galaxy clusters collide, the gas clouds smash into each other, creating shockwaves that span millions of light years. These shockwaves accelerate particles to near the speed of light, creating cosmic rays that traverse the universe. We are constantly being bombarded by these particles, the shrapnel from the collisions happening at our destination. We are already feeling the heat from the fire we are flying towards. Let us reconsider the dipole repeller for a moment. The existence of such a profound void implies that the universe has a bubbly texture. We live on the skin of a bubble, the filament, sandwiched between the empty interior, the void, and the dense node, the attractor. This bubbly structure is a relic of the quantum fluctuations that happened less than a second after the Big Bang. The seeds of our current motion were planted 13.8 billion years ago. We were doomed to fall towards the great attractor before the Earth even formed. The script was written at the beginning of time. We are just now reading the pages. The velocity is relentless. 600 kilometers per second. In the time it took you to hear this sentence, we have moved thousands of kilometers closer to the danger. You cannot feel it because you are moving with the Earth, and the Earth is moving with the Sun, and the Sun is moving with the galaxy. It is the ultimate inertial frame. But if you could step outside the galaxy and put a stick in the ground of absolute space, you would see the Milky Way whiz by like a bullet. We are living on a projectile. The illusion of stillness is the greatest lie our senses tell us. We are not inhabitants of a place. We are passengers on a ride. The philosophical weight of this is heavy. It suggests that place is irrelevant and flow is everything. We are defined by where we are going, not where we are. And where we are going is a place of destruction and rebirth. The Great Attractor is a recycling center for the universe. Old galaxies go in, are torn apart, processed, and turned into new stars, or fed into black holes. It is the metabolic engine of Laniakea. We are food for this engine. Our atoms will eventually be part of a different star, a different planet, or trapped in the singularity of a black hole in the heart of the Shapley supercluster. We are temporary configurations of matter on a permanent journey toward entropy. As we map more of the universe, we find that this pattern repeats. There are other attractors, other voids, other flows. But ours is special because it is ours. It is the specific drain we are circling. The Great Attractor serves as a reminder that the universe is not a static painting to be admired. It is a dynamic, violent, moving machine. It grinds galaxies together to make new structures. It uses gravity as the mortar and stars as the bricks. We are currently just a loose brick, waiting to be placed into the wall. The terror comes from the loss of autonomy. No matter what we do, no matter how advanced we become, we cannot stop the flow. Gravity is the law, and it has no court of appeals. The concept of cosmic horror usually involves aliens or ancient gods, but the Great Attractor proves that simple physics is the scariest genre of all. You don't need Cthulhu when you have gravity. You don't need a haunted house when you have the zone of avoidance. The reality of the physical universe is far more overwhelming than any fiction we can invent. The sheer numbers, quadrillions of suns, millions of light years, billions of years, crush the human ego. We are dust motes in a hurricane, trying to convince ourselves that we are steering the wind. The investigation into the Great Attractor is an investigation into our own insignificance. Yet there is a strange beauty in it. The Great Attractor allows us to map the invisible. By studying how we fall, we learn about the terrain of the dark. We use our own motion as a sensor. We are the probe. The Milky Way is a test particle in the grand experiment of the cosmos. Every measurement of the redshift, every survey of the peculiar velocities, tells us something profound about the nature of mass and space. We are deciphering the code of the universe by reading the speedometer of our own galaxy. It is a dangerous journey, but it is the only way to learn the truth about where we live. The cluster of clusters, this is what Shapley is. It is a metropolis of galaxies. Imagine a night sky with not just stars, but thousands of spiral nebulae visible to the naked eye. That is the view from a planet deep within the supercluster. It would be a sky of breathtaking density. But that beauty comes with the price of instability. Perturbations from passing galaxies would constantly disrupt the Oort clouds of star systems, sending comets raining down on inner planets. Extinction events would be clockwork. The most dangerous place is also the most visually spectacular. The universe hoards its beauty in the same places it keeps its danger. The magnetic fields in these clusters are also immense. They span millions of light years, acting as synchrotrons that accelerate particles to relativistic speeds. These magnetic webs thread through the clusters, connecting galaxies like beads on a string. We are moving into a region of intense magnetism, high radiation, and gravitational chaos. It is the trifecta of cosmic hostility. The Great Attractor is not just a gravity well, it is a storm front, and we are flying right into the eye of the storm with no option to turn around. This realization brings us back to the dipole. The universe has a direction. It is not the same in all directions. There is an up and a down defined by gravity. Down is towards Shapley. Up is towards the void. We are falling down. The ancient intuition that the heavens are perfect and changeless is dead. The heavens are a landslide, and we are just rocks tumbling down the slope. The most dangerous place in space is simply the bottom of the hill, where all the rocks pile up and crush each other. But what happens when we get there? In the far, far future, when all the galaxies of Laniakea have merged, the sky will go dark. The expansion of the universe will push all other superclusters away faster than light. They will vanish. Future astronomers, if they exist, will think that Laniakea is the entire universe. They will see nothing but their own supergalaxy. They will have no evidence of the Big Bang, no evidence of expansion, no evidence of other clusters. They will live in a lonely, static, eternal island of stars. The Great Attractor is the architect of this future isolation. It is gathering us together to lock us away from the rest of existence. This is the end of cosmology. We are living in a privileged time, where we can still see the other galaxies, where we can still measure the expansion, where we can still see the Great Attractor. In the future, the evidence will be gone. The danger is not just physical, it is epistemological. The Great Attractor is destroying the evidence of the universe's origin by binding us so tight that we lose touch with the outside world. We are in the golden age of understanding, simply because we can still see the things that are trying to kill us. So, the next time you feel stationary, remember the speed. Remember the 600 kilometers per second. Remember the zone of avoidance. Remember the monster behind the dust. It is there, it is real, and it is hungry. It is the silent partner in our solar system's journey. We are not just explorers, we are prey. And the hunt has been going on for 13.8 billion years. But is the Great Attractor the only danger? Or is there something even more fundamental? Something that threatens the very atoms you are made of? We have discussed gravity, radiation, and velocity. But we have not discussed the stability of the vacuum itself. The universe rests on a knife edge of energy fields. If one of those fields were to slip, the Great Attractor would be irrelevant. The entire universe would be rewritten. This brings us to the concept of false vacuum. The idea that the empty space we are moving through might not be the lowest possible energy state. If a bubble of true vacuum were to form, perhaps triggered by the extreme energies in a place like the Great Attractor, it would expand at the speed of light. It would transform physics. Chemistry would stop working. Atoms would unbind. It would be a wave of deletion. And because it moves at light speed, we would never see it coming. One moment, stars. The next moment, nothing. The connection between massive gravity wells and vacuum instability is speculative but terrifying. Extreme environments test the limits of nature. If nature breaks, it breaks everywhere. The Great Attractor might be a sleeping giant in more ways than one. It is a concentration of stress on the fabric of space-time. And as we know from engineering, if you stress a material enough, eventually it cracks. The universe might have a breaking point, and we are rushing towards the place where the pressure is highest. We are investigating the crime scene of the cosmos, and every clue points to a violent end. The Great Attractor is the smoking gun of gravity. The dipole repeller is the footprint of the void. The dark flow is the shadow of the unknown. All these pieces fit together to form a picture of a universe that is restless, aggressive, and indifferent to our survival. We are small, soft things in a universe of hard, sharp forces. However, this knowledge is also our shield. By understanding the Great Attractor, we map our place in reality. We stop being passive victims and become active observers. We look the monster in the eye, or at least into the X-ray emission of its eye, and we calculate its mass. We weigh the beast. There is a defiance in science. We may be falling, but we are mapping the fall. We are the only species on Earth that knows we are moving at 600 kilometers per second. That counts for something. As we close this chapter on the Great Attractor, we must prepare to look at the other contenders for the title of Most Dangerous Place. Because while the Attractor is a slow death by gravity, there are other places in the universe that offer a fast death by fire, or a strange death by time dilation. The universe has a diverse menu of destruction. The attractor is just the main course. The journey continues. We have looked at the large-scale structure, the superclusters, the flows. Now we need to look at the specific objects that inhabit these danger zones, the magnetars, the quasars, the rogue black holes, the things that don't just pull you in but rip you apart atom by atom, the monsters that roam the dark forests of the galaxy. Space is not a void, it is a jungle. And in a jungle there are predators. The great attractor is the landscape, the terrain. But the predators are the compact objects that lurk within the terrain. We are about to shift our investigation from the geography of danger to the agents of danger. From the cliff we are falling off to the rocks at the bottom. Prepare yourself. The scale is about to change. We are going from the size of superclusters to the size of cities. But the density is going to increase. The danger is going to become personal. We are moving from the existential dread of the far future to the immediate terror of the extreme present. The great attractor has set the stage. It has established that we are not safe, that we are moving, and that we are blind. Now we turn the lights on. We look at the things that shine in the dark, the things that scream across the radio spectrum, the things that defy logic. This is the end of the beginning. The Laniakea supercluster is our home, and it is a trap. But inside the trap, there are smaller traps. And we are about to step into one. Let us leave the great attractor behind, or rather, let us accept our fate with it and turn our telescope to the next anomaly. The universe is full of monsters. While the great attractor pulls us toward a distant, slow-motion demise, there are singular objects in the universe that offer a much more immediate and violent form of execution. We must now shift our investigation from the massive currents of superclusters to the specific engines of destruction that lurk within them. If the great attractor is the ocean current that drowns you, then black holes are the leviathans swimming in the water, waiting to snap their jaws. These are not merely heavy stars. They are punctures in the fabric of reality where the laws of physics simply give up and quit. The concept of a black hole is the ultimate cosmic horror because it represents the victory of gravity over everything else, over light, over time, and over information itself. When you cross the threshold of a black hole, you are not just entering a dangerous place, you are exiting the universe as we know it. You are being deleted from the server of existence. The boundary of this deletion is called the event horizon, a mathematical line in space that marks the point of no return. To an outside observer, a person falling into a black hole would appear to freeze at the edge, their image fading and reddening forever, trapped in an eternal moment of dying. But for the person falling in, time continues to march forward towards the singularity. This creates a horrifying paradox of perspective. You are dead to the universe, but you are still alive to experience your own destruction. The gravity at this proximity is so intense that it creates tidal forces strong enough to override the electromagnetic bonds holding your body together. This process has a scientifically accurate and terrifying name: spaghettification. The difference in gravitational pull between your feet and your head becomes so extreme that you are stretched into a long, thin stream of subatomic particles, like toothpaste being squeezed from a tube. However, not all black holes are created equal. The ones we find scattered throughout the galaxy, the stellar mass black holes, are the silent landmines of space. They are the corpses of massive stars, collapsed down to a city-sized sphere of darkness. Because they are small, their tidal forces are incredibly violent near the horizon. But the true monsters, the ones that dominate the cosmic landscape, are the supermassive black holes. These giants sit at the center of almost every galaxy, including our own Milky Way. They are not the size of cities. They are the size of solar systems. They do not just consume stars. They consume entire clusters of matter, orchestrating the motion of the billions of stars around them. They are the dark hearts of galaxies, pumping gravity through the veins of the cosmos. And among these giants, there is one that stands apart as the undisputed king of monsters. Deep in the constellation Canes Venati, over 10 billion light-years away, lies a beast that defies all reasonable models of stellar evolution. It is known as 2-618. This is not just a black hole, it is a hyperluminous quasar, a beacon of light powered by the most massive black hole ever discovered. The numbers associated with 2-618 are so large they sound like errors in the data. This object contains the mass of 66 billion suns. To put that in perspective, the black hole at the center of our Milky Way, Sagittarius A, is about 4 million solar masses. Ton 618 is more than 15,000 times more massive than the monster in our own backyard. It is a behemoth that has consumed enough matter to rival the mass of entire small galaxies. It is the largest single entity in the known universe, a dark god sitting on a throne of gravity. The sheer physical size of 618 is the stuff of nightmares. The event horizon of this black hole has a diameter of 390 billion kilometers. If you were to replace our Sun with Ton 618, the event horizon would swallow not just Earth, Mars, and Jupiter, but it would extend more than 40 times beyond the orbit of Neptune. A beam of light would take weeks just to cross the diameter of its shadow. It is an abyss so wide that it could swallow our entire solar system without even burping. This object represents the upper limit of how big a black hole can physically grow before it disrupts the galaxy capable of feeding it. It is an ultra-massive black hole, a category invented because supermassive was no longer a sufficient adjective to describe the horror of its scale. But Ton 618 is not just a dark void, it is a quasar. A quasar is an active galactic nucleus, a black hole that is feeding so voraciously that the infalling matter heats up to incredible temperatures. The friction within the accretion disk, the swirling whirlpool of doomed matter, generates more luminosity than thousands of galaxies combined. Ton 618 shines with a brightness of 140 trillion suns. It is so bright that we can see it from the other side of the universe. This creates a terrifying contradiction. The darkest object in the universe is also the brightest. It is a lighthouse of death. Any planet within thousands of light years of this object would be sterilized by the intense ultraviolet and X-ray radiation blasting from the accretion disk. It is a furnace that burns with the energy of consumption. The energy release from a quasar like Ton 618 is violent enough to drive galactic winds. These are streams of particles moving at a fraction of the speed of light that blow outwards, stripping the surrounding galaxy of the gas needed to form new stars. This brings us to a chilling realization. Quasars are galaxy killers. They don't just eat matter, they shut down the life cycle of their host galaxy. By heating up and blowing away the cold gas clouds, a quasar effectively sterilizes its environment, preventing the birth of any new suns. Ton 618 is a tombstone. It marks the location where a galaxy committed suicide by feeding its central monster too much, too fast. It is a monument to the destructive power of unbridled gravity. While Ton 618 is far away, there are dangers much closer to home that operate on similar principles. We must talk about blazars. A blazar is a quasar with one critical difference. Its jet is pointing directly at us. When a black hole consumes matter, it ejects twin jets of plasma from its poles, traveling at 99.9% the speed of light. If Earth happens to be located down the barrel of this cosmic gun, we see a blazar. One such object is Markarian 421, located about 400 million light-years away. It is an active galaxy firing a high-energy particle beam straight at our solar system. While the distance protects us, the fact remains that we are in the crosshairs of a galactic sniper. If a blazar were closer, within our own local group, the beam would strip our atmosphere and boil our oceans in an instant. The physics of these jets involves the twisting of magnetic fields. As the black hole spins, it drags the magnetic field lines of the accretion disk, winding them up like a spring until they snap. This releases an explosive amount of energy, channeling plasma into a focused beam. This is a particle accelerator built by nature, vastly more powerful than the Large Hadron Collider. The particles in these jets are accelerated to such energies that they experience time dilation. For a particle in the jet, the journey of millions of light years takes only minutes. We are being bombarded by cosmic rays from these sources constantly. Every second, high-energy particles from deep space pass through your body, tiny bullets fired by a black hole millions of years ago. Now, let us move to a danger that is less about size and more about sudden, invisible catastrophe, the gamma ray burst, GRB. A gamma-ray burst is the most energetic electromagnetic event known to occur in the universe. In a few seconds, a GRB releases more energy than our Sun will produce in its entire 10 billion-year lifetime. These bursts are thought to be caused by the collapse of massive stars into black holes, or the collision of two neutron stars. They are flashes of doom. If a gamma-ray burst were to happen within the Milky Way, pointing at Earth, it would be an extinction-level event. The ozone layer would be instantly vaporized, exposing all life to lethal solar UV radiation. The atmosphere would glow with nitrogen oxides, creating a toxic brown smog that would block the sun and trigger a global ice age. The scary part about gamma-ray bursts is that they travel at the speed of light. This means there is absolutely no warning system. We cannot see it coming because the light of the explosion arrives at the exact same time as the radiation that kills us. You would be walking down the street one moment, and the next, the sky would burn. Scientific investigation suggests that a gamma-ray burst may have been responsible for the Ordovician Silurian extinction event 450 million years ago, which wiped out 85% of all marine species. The fossil record shows a pattern consistent with a sudden burst of radiation followed by global cooling. It is a smoking gun that suggests we have been hit before, and statistically, it is only a matter of time before we are hit again. Astronomers have identified potential ticking time bombs in our own galaxy that could produce a gamma-ray burst. One of the primary suspects is the star system WR-104, located about 8,000 light-years away in the constellation Sagittarius. WR-104 contains a Wolf-Rayet star, a massive, unstable star that is on the brink of going supernova. Observations show that the rotational axis of this star is aligned almost precisely with Earth. This means that when it finally collapses, the resulting GRB jet could be aimed directly at us. While 8,000 light-years is a significant distance, a focused beam of gamma radiation carries its punch over vast ranges. We are staring down the barrel of a loaded gun, waiting for the star to pull the trigger. Wolf-Rayet stars like the one in WR-104 are rare and beautiful monsters. They burn their fuel at a prodigious rate, creating strong stellar winds that form intricate pinwheel spirals of dust around them. But this beauty masks a violent instability. These stars have stripped away their outer hydrogen layers, exposing their superhot helium cores. They're living on borrowed time, fusing elements heavier and heavier until they hit iron, the cosmic dead end. Once iron is formed in the core, fusion stops, gravity takes over, and the star collapses in a fraction of a second. If the star is spinning fast enough, that collapse generates the GRB. The fact that WR-104 is looking right at us is a cosmic coincidence that keeps astrobiologists awake at night. But there is an object even denser and more magnetic than a standard neutron star, the magnetar. If black holes are the monsters of gravity, magnetars are the monsters of electromagnetism. A magnetar is a type of neutron star with an incredibly powerful magnetic field, up to a quadrillion times stronger than Earth's magnetic field. To understand this power, imagine a magnet so strong that if it were placed halfway to the moon, it would wipe every credit card on Earth and jam every electronic device. If a magnetar were to fly through our solar system at a distance of 100,000 kilometers, its magnetic field would be strong enough to rip the electrons away from your atoms. You wouldn't just die. Your molecular structure would simply dissolve into a cloud of monatomic ions. The crust of a magnetar is under immense strain from these magnetic fields. Occasionally, the crust cracks, causing a starquake. This is not like an earthquake on Earth. It is a cataclysmic release of energy that triggers a flare of soft gamma rays. In 2004, a magnetar known as SGR 1806-20, located 50,000 light-years away on the other side of the galaxy, experienced a starquake. In 1/10 of a second, it released more energy than the Sun emits in 150,000 years. The flash was so bright it bounced off the Moon and partially ionized the Earth's upper atmosphere, expanding it and altering satellites' orbits. Remember, this object was 50,000 light-years away. If it had been within 10 light-years, the ozone layer would have been destroyed and mass extinction would have followed. SGR 1806-20 holds the record for the most powerful explosion ever witnessed within our galaxy. It serves as a stark reminder that the Milky Way is not a safe harbor. It is a minefield. Magnetars are difficult to detect until they flare, meaning there could be one drifting closer to us right now, silent and invisible, waiting for its crust to crack. The magnetic field is so intense that it distorts the vacuum of space itself, causing a phenomenon called vacuum birefringence. In the vicinity of a magnetar, empty space acts like a prism, splitting light in ways that shouldn't be possible. It is a region where the fundamental properties of light and matter are warped by the sheer intensity of the magnetic force. The most dangerous place might not be a specific star, but a region of nothingness. Let us investigate the Bootes Void, often called the Great Nothing. This is a sphere of space roughly 330 million light-years in diameter. Statistically, a region of this size should contain roughly 2,000 galaxies. But in the Bootes Void, we have found only 60. It is a ghostly, empty desert in the cosmos. If the Milky Way were in the center of the Bootes Void, we would not have known other galaxies existed until the 1960s. The night sky would be completely black beyond our own stars. The darkness would be absolute. This void creates a feeling of existential dread because we don't fully understand how it formed. It is too big to be a simple random fluctuation. Some theories suggest that the Bootes Void is the result of galaxy mergers on a hyperscale, where smaller voids coalesced into a supervoid. Others propose more exotic explanations, like the influence of a Type 3 civilization expanding and Dyson swarming every star in its path, effectively dimming the lights of an entire region. While this is highly speculative fiction, the Tabby star anomaly reminds us that we are always looking for signs of mega-engineering. But the most likely reality is simply that gravity is a ruthless segregator. It pulls matter into filaments and walls, leaving the voids to grow emptier and darker over eons. The Bootes Void is a glimpse of the far future of the universe, cold, dark, and lonely. A place where light goes to die. Let us return to the heart of our own galaxy, the galactic center. This is a chaotic, radioactive downtown district located 26,000 light-years from Earth. It is the most dangerous place in the Milky Way. The stellar density here is 1 million times higher than in our solar neighborhood. If you lived on a planet near the galactic center, the night sky would be bright enough to read by, dazzling with the light of 1 million suns. But this beauty is deadly. The proximity of so many stars means that supernovae go off frequently, bathing the region in sterilizing radiation. Every few thousand years, a star explodes nearby. Life here would be constantly resetting, unable to gain a foothold before the next wave of radiation wipes the slate clean. At the very center sits Sagittarius A, the supermassive black hole that anchors our galaxy. While it is currently quiet compared to a quasar, it has a history of violence. Evidence shows that as recently as a few million years ago, Sagittarius A was active, spewing jets of energy called Fermi bubbles that extend 25,000 light-years above and below the galactic plane. These bubbles are visible in gamma rays and X-rays, ghost-like remnants of a past feeding frenzy. They serve as a warning that our sleeping dragon wakes up periodically. If a gas cloud or a stray star wanders too close, Sagittarius A will reignite, flooding the inner galaxy with lethal X-rays. We are safe only because of our distance and the current starvation diet of the black hole. The galactic center is also home to the highest concentration of magnetars and neutron stars. It is a graveyard of massive stars. The gravity is so intense that stars whip around the black hole at speeds of 5,000 kilometers per second. This is known as the S-star cluster. These stars are living on the edge of the abyss, constantly tormented by tidal forces. Watching them orbit over decades has provided the definitive proof of general relativity, but it also illustrates the violence of the environment. It is a cosmic mosh pit, where the dancers are suns and the music is gravity. Any planet in this region would be flung out of orbit, frozen in the dark, or cooked by the radiation of its neighbors. There is a specific type of planet that might be the most terrifying place to physically stand. The rogue planet. These are worlds that have been ejected from their solar systems by gravitational interactions. They drift through the interstellar void, untethered to any sun. In the Milky Way alone, there may be billions of these orphans. Without a star, the surface temperature is near absolute zero. The atmosphere freezes and snows out onto the surface as nitrogen and oxygen ice. It is a world of eternal night, but the horror lies in the possibility that life could still exist there. Deep beneath the ice, powered by the heat of radioactive decay in the core, liquid oceans could harbor blind, huddled ecosystems. Imagine a civilization evolving on a rogue planet. They would have no concept of day or year. They would have no concept of stars. Their universe would be the dark ocean under the ice. If they ever drilled to the surface and looked up, they would see a sky filled with strange, unmoving lights, the distant stars, but no sun to warm them. They would be the ultimate cosmic orphans, drifting alone in the dark. But recently, scientists have found hot rogue gas giants that are still glowing from the heat of their formation, drifting alone. These worlds are storms of molten rain in the darkness, visible only by their faint infrared heat signature. They are the ghosts of the planetary family. Moving back to the high-energy scale, we must discuss the kilonova. This is the explosion resulting from the collision of two neutron stars. It is 1,000 times brighter than a standard nova. This event is the universe's gold factory. The extreme pressure and neutron density allow for the rapid capture process, process, creating heavy elements like gold, platinum, and uranium. The gold in your jewelry was likely forged in the death throes of two colliding city-sized atomic nuclei. But to be near a kilonova is to be vaporized by the birth of heavy metals. The gravitational waves from such an event are powerful enough to ripple spacetime across billions of light-years, ringing the universe like a bell. In 2017, humanity detected such an event, GW170817. We heard the chirp of the gravitational waves and saw the flash of light. It confirmed that these monsters exist and that they are responsible for the heavy elements in the universe. But it also highlighted the violence of creation. To make a wedding ring, the universe has to smash two dead stars together at a significant fraction of the speed of light. The most dangerous places are also the most creative places. Destruction and creation are synonymous in high-energy astrophysics. You cannot have the gold without the explosion. But what about the danger of the false vacuum we mentioned earlier? Let us dig deeper. The Higgs field gives particles mass. But if the current value of the Higgs field is not the absolute minimum, we are in a metastable state. It is like a ball resting in a small dip on a mountainside. It looks stable, but there is a deeper valley further down. If a high-energy event kicks the ball over the ridge, it will roll down to the true bottom. This transition would release a bubble of energy that expands at light speed, changing the laws of physics inside the bubble. Protons might decay. Chemistry would become impossible. The universe inside the bubble would collapse into a lower energy state, effectively deleting the universe outside. This is arguably the most dangerous place, because the place is everywhere. The danger is inherent in the fabric of space itself. We might be living on a trap door that could open at any moment. Some physicists worry that extremely high-energy particle collisions, far beyond what we can do at CERN, but possible in nature, could trigger this phase transition. If a cosmic ray with enough energy hits a particle in just the right way, it could nucleate a vacuum decay bubble. We wouldn't know it happened. The wave of destruction moves at the speed of light, so we would never see the bubble approaching. We would simply vanish. The concept of strange matter offers another flavor of contagion. Inside the core of a neutron star, the pressure is so high that protons and neutrons might dissolve into a soup of quarks. Some theories suggest a stable form of matter called strangelets, made of up, down, and strange quarks. The scary part about strangelets is that they could be contagious. If a strangelet comes into contact with normal matter, it could convert that matter into more strange matter. It would trigger a chain reaction, turning a star or a planet into a hot, inert lump of strange quark soup. It is the ICE-9 scenario of particle physics. While strange matter is hypothetical, the neutron stars that might birth it are very real. They are the densest objects that have a surface. A teaspoon of neutron star material weighs about 1 billion tons, the same as Mount Everest. If you were to drop a marshmallow onto a neutron star, it would hit the surface with the energy of a nuclear bomb due to the gravity. The escape velocity is half the speed of light. These objects are the border towns between reality and the black hole abyss. They spin at hundreds of times per second, acting as the flywheels of the galaxy. We have surveyed the monsters of the dark, but we must not forget the wandering black holes. Not all black holes stay put in the center of galaxies. When galaxies collide, their central black holes can be kicked out by gravitational recoil. These recoiling black holes roam the intergalactic void at millions of miles per hour. There could be a supermassive black hole moving through the empty space between the Milky Way and Andromeda right now, invisible, silent, and massive. If it were to pass through our solar system, it wouldn't even need to hit us. Its gravity would simply eject the Earth from the Sun's orbit, sending us into the dark. The idea of the solar system being disrupted is not just paranoia. It is a statistical inevitability on long timescales. The Great Attractor pulls the galaxy, but local stars pull at each other. Gliese 710 is a star that is currently heading towards us. In about 1.3 million years, it will pass within the Oort cloud, the shell of comets surrounding our system. This flyby will disturb the comets, sending a shower of long-period comets raining down on the inner solar system. This could trigger an era of bombardment similar to the one that killed the dinosaurs. The danger is not always an exotic explosion. Sometimes it is just a rock thrown by a passing stranger. Let's reconsider the zone of avoidance in this context. We know the Great Attractor is there, but what if there is a Great Repeller closer to us? The local void is a region of emptiness directly adjacent to our galaxy. We are moving away from it at 260 kilometers per second. This void is expanding, pushing the local sheets of galaxies against the Great Attractor. We are being squeezed between the hammer of the attractor and the anvil of the void. This dynamic pressure is what shapes the filaments of the cosmic web. We are living in a high-pressure system of gravity. The cosmic web itself contains shock waves of gas. When clusters merge, they create shock fronts that are millions of light-years wide. These are the largest structures in the universe. The temperature behind the shock front can reach 100 million degrees. These are not sound waves, as space is a vacuum, but density waves in the thin plasma. They are tsunamis of hot gas. If a galaxy falls into one of these shocks, its gas is stripped away instantly. It is ram pressure stripping. The galaxy is flayed alive, leaving only the skeleton of stars behind. We see evidence of this stripping in the jellyfish galaxies. These are galaxies with long tentacles of gas trailing behind them as they plunge into a cluster. The tentacles are the blood and guts of the galaxy, being ripped out by the pressure of the intracluster medium. It is a violent, visceral process. To live in a jellyfish galaxy would be to watch your night sky be torn away. The star-forming regions are dragged out into the tail, creating new, orphan stars in the wake of the dying galaxy. It is a scene of cosmic gore. The universe is a recycling machine, but the process is brutal. The most dangerous place is really just the intake valve of this machine. Whether it is the event horizon of Tone 618, the jet of a blazar, or the shock front of the Great Attractor, they all serve the same function: to mix, heat, and redistribute matter. We assign the word danger because we value our biological continuity. The universe does not. The universe values entropy. The Great Attractor is just a very efficient entropy engine. There is a theory called the Big Rip. If dark energy, the mysterious force expanding the universe, continues to accelerate, it might eventually overcome gravity, electromagnetic, and nuclear forces. In a Big Rip scenario, the expansion becomes infinite. First, the galaxy clusters are torn apart. Then, the galaxies themselves. Then, solar systems. Then, planets. Finally, atoms themselves are ripped apart. The universe ends not in a crunch or a freeze, but in a shredding. Every point in space becomes the most dangerous place, because space itself becomes a weapon. The timing of the Big Rip depends on the equation of state of dark energy. W. If W is less than -1, we are in phantom energy territory. Phantom energy grows stronger as the universe expands. It is a runaway feedback loop. While current data suggests W is close to -1, meaning a cosmological constant, the error bars allow for a Big Rip scenario in some 22 billion years. It is the ultimate cosmic horror ending, the disintegration of reality from the top down to the bottom up. But let us pull back to the present. The Fermi paradox remains the ghost in the room. If the universe is 13.8 billion years old, where is everyone? Perhaps the answer lies in the frequency of these dangerous events. Maybe 99% of civilizations are wiped out by a local gamma-ray burst or a supernova before they can leave their planet. This is the Great Filter Hypothesis. The Great Attractor and its hazardous environment might be the ultimate filter. We might be the survivors simply because we live in the quiet boondocks of the universe, far from the busy, deadly city centers of the clusters. Our location in the Milky Way is crucial. We are in the galactic habitable zone, not too close to the dangerous center, and not too far out where metallicity is too low to form rocky planets. We are in the Goldilocks zone of the galaxy. But this zone is not static. As the Milky Way merges with Andromeda, the habitable zone will be disrupted. Stars will be shuffled. We might be thrown into the center, or cast out into the void. The safe harbor is temporary. The investigation of space is an investigation of risk. Every time we discover a new class of object, quasars, magnetars, blazars, we add a new entry to the list of things that can kill us. But the most terrifying thing is what we haven't found yet. Primordial black holes, atom-sized black holes left over from the Big Bang. They could be passing through the Earth every day. While small ones would pass through unnoticed, a larger one could settle in the Earth's core and eat the planet from the inside out. We would never know until the earthquakes started and didn't stop. The dark matter halo that surrounds our galaxy is also a mystery. It is 5 times more massive than the visible matter. We are swimming in it. If dark matter has any non-gravitational interactions, if there is a dark sector of physics, we are completely blind to it. There could be dark stars or dark planets interpenetrating our world, ghost entities that we walk through without knowing. The idea that we only see 5% of the universe is the ultimate humbling fact. The most dangerous place might be right here, in the shadow world we can't touch. Let's consider the oh my god particle. In 1991, a cosmic ray was detected with the kinetic energy of a baseball traveling at 60 miles per hour, packed into a single proton. It was moving at 99.999999999999999999999999999999999999999999999999999999999999999999999999999999999. The speed of light. We still don't know what accelerator in the universe is capable of producing such a particle. It defies the GZK limit. Was it a jet from a blazar, a magnetar flare, or something else? That particle hit our atmosphere. If it had hit a person, it would have caused cellular damage. The universe is taking potshots at us, and we don't know who the shooter is. The mystery of fast radio bursts falls into the same category. These are millisecond-long blasts of radio energy from billions of light-years away. Some repeat, some don't. Are they magnetars? Collapsing stars? Alien propulsion systems? We receive them daily now. The universe is chirping with high-energy signals. It sounds like a war zone out there. We are just the listeners in the quiet bunker, hearing the distant explosions. As we delve deeper into the micro scale of danger, we realize that stability is an illusion. The sun seems stable, but it is a fusion bomb held in check by gravity. The Earth seems stable, but it is drifting. The vacuum seems empty, but it is seething with virtual particles. The Great Attractor is just the largest manifestation of a universal truth. Everything is falling, everything is changing, and nothing is safe forever. The heat death of the universe is the final danger, the ultimate entropy. When all the stars burn out, and all the black holes evaporate via Hawking radiation, the universe will be a sea of cold photons. No information processing will be possible. Time itself will lose meaning because nothing changes. The most dangerous place is actually the end of time, because that is where existence becomes impossible. We are currently in the brief, flashy era of the universe where life is possible. We should cherish the danger, because the alternative is the void. But before the heat death, we have the collision, the Milky Way and Andromeda. We have named it Milkomeda. The night sky will be spectacular. 2 bands of Milky Ways crossing in the sky. But the chaotic gravity will be a nightmare for navigation. Any civilization around at that time will have to survive the merger. It will be a test of endurance. The Great Attractor will be watching from a distance, waiting to pull the wreckage of the merger towards it. The story of the Great Attractor is the story of gravity's long victory. Gravity is the weakest force, but it has infinite range and it is always attractive. It wins in the end. It builds the galaxies, and it crushes them. It is the patient killer. It doesn't need to hurry. It has all of eternity to bring us to the center. We are fighting a losing battle against the curve of space-time. So when we ask, what is the most dangerous place in space? The answer depends on your time frame. In the short term, a blazing magnetar or a nearby supernova. In the medium term, the collision with Andromeda. In the long term, the Great Attractor in the Shapley supercluster. In the ultimate term, the vacuum decay or the Big Rip. Dangerous fractal. It exists at every scale. Yet, we are drawn to these places. We study them. We build telescopes to see the monsters. Why? Because we are the descendants of survivors. We are curious. The cosmic horror is also cosmic wonder. The Great Attractor is a magnificent beast. Ton 618 is a king. We bow to the scale of the universe even as we fear it. It is the sublime, the mixture of terror and awe. As we prepare for the final leg of our journey, we must look at the human element. How do we cope with this knowledge? How do we live on a planet that is a dust mote falling into a furnace? The answer lies in our perspective. We are the universe becoming aware of itself. We are the way the Great Attractor knows it exists. We are the witnesses. And the witness has a duty to watch, even if the view is terrifying. We must now confront the most unsettling implication of the Great Attractor, the distortion of time itself. According to Einstein's general relativity, gravity does not just bend space, it dilates time. The closer you get to a massive object, the slower time moves relative to the outside world. This means the Great Attractor is not just a place in space, it is a slow-motion trap. If you were to approach the core of the Shapley supercluster, the seconds on your watch would tick slower than the seconds back on Earth. You would be aging slower, but the universe outside would be dying faster. By the time you looked back, the stars you knew might have already burned out. You would be stepping into the future, a future where the lights have gone out. This time dilation effect reaches its zenith at the event horizon of a black hole, but on the scale of a supercluster, it creates a, quote, temporal gradient. The galaxies deep inside the cluster are experiencing a different flow of history than the galaxies on the outskirts. This leads to a chilling thought. Civilizations in the core of the Great Attractor might be out of sync with the rest of the universe. They are living in a gravity well so deep that they are essentially cut off from the timeline of the cosmos. To them, the universe is aging rapidly. To us, they are frozen in amber. Gravity is the ultimate isolator, walling off sections of reality with the invisible bricks of time. Let's pivot to the Great Wall structures again. The Hercules Corona Borealis Great Wall is the largest known structure in the universe, spanning 10 billion light-years. It is a filament of galaxies so vast that it challenges the cosmological principle, which states the universe should be uniform on large scales. The existence of such a structure suggests that the clumping of matter is far more extreme than our models predicted. The Great Attractor is just a local knot in a much larger, terrifying web. We are like ants on a single thread of a spiderweb that stretches across a room we cannot see. The web is vibrating, and we are just feeling the tremors. The cosmic void is the antithesis of the wall. The Eridanus supervoid is a cold spot in the cosmic microwave background that spans a billion light-years. It is a hole in the universe. Some theories suggest this might be the imprint of a parallel universe rubbing against ours, leaving a bruise on the skin of reality. If true, the dangers of space are not limited to our own dimensions. We could be colliding with other brains, other realities, in a higher dimensional bulk. The Great Attractor pulls us in 3D space, but what is pulling us in the 4th or 5th dimension? We are drifting in directions we don't even have names for. Back in our own galaxy, let's look at the kill zone of the galactic core again. The density of stars is not the only problem, it's the velocity. Stars in the core are buzzing around like angry bees. This increases the chance of stellar flybys. A star passing within 100 astronomical units of a planetary system would strip away its outer planets and destabilize the inner ones. A civilization in the core would face constant orbital chaos. Their years would change length. Their seasons would become erratic. Stability is a luxury of the suburbs. In the city center, chaos is the only constant. The local bubble is the cavity in the interstellar medium that our sun is currently traveling through. It was created by supernova explosions millions of years ago. We are effectively moving through the expanding exhaust of dead stars. This bubble has very low density, which is why we can see the stars so clearly. But we are approaching the edge of the bubble. When we exit the local bubble and enter a denser cloud of interstellar gas, the galactic wind will compress our heliosphere. This could expose Earth to higher levels of cosmic radiation, altering our climate and our genetic mutation rates. The safety of our bubble is temporary. There is a specific type of star called a Wolf-Rayet star, mentioned earlier with WR104. But let's look at the Eta Carinae system. It is a ticking time bomb located 7,500 light-years away. In the 1840s, it underwent a, quote, eruption, becoming the second brightest star in the sky, surviving an explosion that would have destroyed a lesser star. It is essentially a supernova in slow motion. It teeters on the brink of total collapse. When it finally goes, it will be a hypernova, potentially releasing a gamma-ray burst. We are watching a fuse burn down, but we don't know how long the fuse is. It could explode tomorrow or in 10,000 years. The zombie stars are another anomaly. Type Ia supernovae happen when a white dwarf steals too much matter from a companion. Usually the white dwarf is destroyed, but sometimes it survives. It becomes a type Ia supernova remnant, a battered, half-dead star speeding away from the explosion. These zombie stars wander the galaxy, glowing with strange chemical signatures. They are the undead of the stellar population, refusing to lie down. It is a reminder that even death in the cosmos is not always clean or final. Let's consider the Planet 9 hypothesis in the context of danger. If a massive planet exists in the outer solar system, its gravity could periodically nudge comets from the Kuiper Belt toward Earth. Some scientists have linked the periodic mass extinctions on Earth to the orbital period of this hypothetical planet. We might be sharing our solar system with a silent killer, a shepherd that occasionally throws a wolf into the flock. The call is coming from inside the house. The Kessler syndrome is a man-made danger, but it mimics the cosmic ones. If we pollute low Earth orbit with too much debris, a chain reaction of collisions will create a shell of shrapnel around the planet. We would be trapped. No rockets could leave. No satellites could survive. We would be imprisoned on Earth, cut off from the universe just as we are starting to explore it. The great attractor pulls us, but we might build our own cage before we even get there. It is the irony of intelligence. We can engineer our own isolation. We must also discuss vacuum energy in terms of expansion. Dark energy is pushing the universe apart. But what if dark energy is not constant? What if it decays? If dark energy turns into normal energy, the expansion could stop and reverse. The universe would begin to contract. The Big Crunch would become the destiny of everything, not just Laniakea. The sky would turn blue, then violet, then blinding white as the background radiation heats up. We would be cooked in a cosmic oven. The end of the universe would be fire, not ice. The Great Filter might also be biological. Maybe the danger isn't the stars. Maybe it's the inevitable path of technology. Every civilization might invent a technology that destroys it. Nuclear weapons, AI, engineered pandemics. The silence of the universe is a graveyard of civilizations that couldn't handle their own power. The great attractor is irrelevant if you blow yourself up first. We are walking a tightrope over a canyon of self-destruction, worrying about the storm on the horizon while ignoring the fraying rope. Let's return to spaghettification. It is not just a black hole phenomenon. If you get close enough to a neutron star, the tidal forces can rip you apart before you even touch the surface. But the magnetic field would kill you first. It would distort the electron clouds in your atoms, turning your chemistry into long, thin needles. You would dissolve into a soup of polymer-like chains. The physics of extreme objects is a catalog of gruesome ways to die. The pulsar is a rotating neutron star that acts like a cosmic lighthouse. Some rotate hundreds of times a second. These are millisecond pulsars. The precision of their ticking rivals atomic clocks. But this precision is deadly. They emit beams of radiation that sweep across the sky. If you are in the path of the beam, you are fried periodically. It is a strobe light of death. We use them for navigation maps, like on the Voyager record, essentially drawing a map using the locations of the deadliest lighthouses in the galaxy. The galactic cannibalism is a standard part of galaxy evolution. The Milky Way is currently eating the Sagittarius dwarf spheroidal galaxy. We can see the streams of stars being ripped from it. We are the monsters. To a civilization in the Sagittarius dwarf, the Milky Way is the great attractor. We are the predator that is consuming their home. Perspective changes everything. We fear the Shapley supercluster, but we are the Shapley supercluster to the smaller galaxies around us. Hypervelocity stars are stars that have been kicked out of the galactic center by the supermassive black hole. They travel at millions of miles per hour, fast enough to escape the galaxy entirely. One of these stars could plow through a nebula, triggering a wave of star formation or disrupt a planetary system. They are the rogue agents of the galaxy, unbound by the rules of the disk. They are lonely, fast, and dangerous. The coronal mass ejection, CME, is the danger from our own sun. In 1859, the Carrington event hit Earth. If it happened today, it would fry our power grids, destroying modern civilization in days. We would be back to the 1800s, but with 8 billion people to feed. The sun is a benevolent dictator, but it has a temper. We are living next to a bomb that goes off randomly. Cosmic rays are high-energy protons traveling through space. They cause errors in computers, bit flips. A single particle can flip a 0 to a 1 in a plane's computer or a voting machine. The universe is constantly meddling with our data. We build shields, but the high-energy ones punch right through. We are being irradiated by the ghosts of distant supernovae every second of every day. The Unruh effect suggests that an accelerating observer sees a thermal bath of particles where an inertial observer sees nothing. If you accelerate fast enough, empty space becomes hot. This means that danger is relative to your motion. If we build a spaceship that accelerates too hard, the vacuum itself will burn us. The speed limit of the universe is enforced by fire. Boltzmann brains are a terrifying thought experiment. In an eternal universe, it is more likely for a single brain to spontaneously fluctuate into existence out of the quantum vacuum, complete with false memories, than for an entire universe to evolve. You might be a Boltzmann brain that formed 1 second ago and will dissolve 1 second from now. Your entire life, your memories, this video, it could all be a momentary hallucination of entropy. It is the ultimate solipsistic horror. The great attractor is pulling us, but the expansion of the universe is pushing us. This tug-of-war defines our future. Eventually, the expansion wins globally, but gravity wins locally. We will be crunched into a ball while the rest of the universe flees. It is a claustrophobic destiny. We are being locked in a room while the house burns down. Strange matter again. If a neutron star spins up enough, it might eject strangelets. These could drift through space. If one hits the sun would convert into a strange star. It would go dark and dense. Earth would freeze. The contagion scenario is low probability but high impact. It is the zombie apocalypse of particle physics. The dark forest theory of the Fermi paradox suggests that the universe is full of life, but everyone is hiding because there are predators patrolling the galaxy. If you transmit, you die. Humanity has been broadcasting radio for 100 years. We are shouting in the jungle. We might have already attracted the attention of something we don't want to meet. The silence is safety. The noise is danger. Super-Earths are common in the galaxy, but gravity on a super-Earth is crushing. Launching a rocket would be impossible. A civilization there would be trapped forever on their planet, unable to explore. They would look up at the stars and know they can never reach them. It is a gravity prison. We are lucky. Earth is small enough to escape. The Roche limit is the distance within which a celestial body, held together only by its own gravity, will disintegrate due to a second celestial body's tidal forces. If the moon gets too close to Earth, it will shatter into a ring system. Debris would rain down for centuries. We would have a beautiful ring but a destroyed surface. Gravity is a harsh mistress. Information paradox. Black holes destroy information. This violates quantum mechanics. It suggests our understanding of reality is fundamentally flawed. If information can be lost, then the past is not secure. History can be erased. The black hole doesn't just kill you, it makes it so you never existed. The cold spot in the CMB might be a supervoid or a bruise from a multiverse collision. If it's a collision, it means universes can bump into each other. A collision with a universe with different physical laws would be catastrophic. It would be like a bubble of antimatter hitting matter. Total annihilation. Rogue black holes are invisible. We only find them via microlensing, when they warp the light of a star behind them. We have found a few. But for every one we find, there are thousands we miss. They are the sharks in the water at night. You don't see the fin until it breaks the surface. The Hulse-Taylor binary is a pulsar system that is slowly decaying. It proved gravitational waves exist. But it also proves that orbits decay. The Earth is slowly, very slowly, radiating gravitational waves. We are spiraling into the sun. It will take longer than the sun's life, but the principle holds. Stability is a lie. Everything falls eventually. The fine-tuned universe argument says that if the physical constants were slightly different, life couldn't exist. But this implies that there are other universes where the constants are different. Dead universes. Broken universes. We are walking on a tightrope of probability. The Great Attractor is just one feature of a universe that barely tolerates our existence. Entropic gravity is a theory that suggests gravity isn't a fundamental force, but a side effect of entropy. If true, it means the Great Attractor is just a manifestation of the universe's tendency towards disorder. We are falling because the universe wants to be messier. We are dust bunnies collecting in the corner of the room. The Higgs boson is the God particle, but its mass suggests the universe is metastable. We are living on thin ice. The doomsday calculation suggests we are likely in the end times of humanity because the population is so high. Statistically, you are likely to be born when there are the most people. This implies a crash is coming. The math of probability is the scariest script of all. Gray goo, nanotech consuming the world, is a sci-fi version of the Strangelet scenario. But biological viruses are nature's nanobots. Panspermia theories suggest viruses could travel on comets. We might be hit by a plague from the stars. The Andromeda strain isn't just a book. It's a biological possibility. Space is not sterile. The Great Silence. We listen to the radio waves and we hear nothing. Just the hiss of the Big Bang and the roar of the black holes. The silence is heavy. It implies that intelligence is rare, or fleeting, or hiding. Being alone in a haunted house is scary. Being alone in a haunted universe is terrifying. Time travel to the past is likely impossible, but time travel to the future is real. Just orbit a black hole. But it's a one-way trip. You can never go back. The Great Attractor is a time machine that only has a forward gear. We are all time travelers, rushing into a future we cannot predict. The Event Horizon Telescope gave us the first picture of a black hole. It looked like a burning ring of fire. It was the Eye of Sauron made real. It stared back at us. That image changed human consciousness. We looked into the abyss and we captured it on a hard drive. We proved the monsters are real. The Lyman Alpha Forest is the absorption lines in quasar spectra caused by gas clouds. It maps the skeleton of the universe. It shows the filaments of the cosmic web. We are trapped in this web. We are the prey, and the spider is gravity. The map of the universe looks like a trap. Neutrinos pass through the Earth by the trillions. We are transparent to them. If there were high-energy neutrinos that interacted more strongly, we would be cooked. The ghost particles are harmless only because they ignore us. If the laws of physics tweaked slightly, the ghosts would become solid. The Planck length is the pixel size of the universe. Below this, space makes no sense. The universe is resolution limited. Are we in a simulation? If so, the Great Attractor is just a line of code. A subroutine for garbage collection. We might be deleted when the simulation ends. Retrograde orbit. Triton orbits Neptune backwards. It will eventually spiral in and break apart. The solar system is full of these doomed dances. It is a clockwork mechanism that is slowly winding down. The springs are rusting. The gears are grinding. Galactic habitable zone limits life to a thin ring. Too close to the center? Radiation. Too far? Not enough metals. We are walking a tightrope. The fact that we exist is a statistical miracle. We shouldn't be here. The universe is hostile to life. We are the exception, not the rule. The dipole repeller pushes us. The great attractor pulls us. We are in a current. But currents have turbulence. We could be caught in an eddy, a region of chaotic flow. The path to the attractor is not straight. It is a winding road through the dark. Hawking radiation means black holes eventually die, but it takes googles of years. The black hole era of the universe will last far longer than the star era. We are living in the brief flash of the beginning. The universe will be dark for almost all of its history. We are the morning dew that evaporates before noon. White holes, the theoretical opposite of black holes. They spit things out. Are they real? Is the Big Bang a white hole? Are we the ejecta of a white hole? If so, we are just the vomit of a higher dimensional monster. A sobering thought. The cosmic horizon is shrinking in a way. As expansion accelerates, galaxies leave our horizon. We are losing contact with the universe. The observable universe is getting lonelier. We are being ghosted by the cosmos. Technosignatures. We look for Dyson spheres. We find nothing. Maybe advanced civilizations don't build big. Maybe they upload into computers and hide in the quantum realm. Maybe the silence is a choice made to avoid the great attractor of attention. The solar apex, the direction the sun travels. We are heading toward Vega, but Vega won't be there when we arrive. Everything is moving. It is a dance where the partners are changing every second. You can never step in the same river twice, and you can never be in the same place in space twice. Intergalactic void, the space between galaxies. It is the truest nothing, a single atom per cubic meter. If you were stranded there, you wouldn't rot, you would freeze and drift forever. A statue in the dark. The ultimate loneliness. Relativistic jets are the flamethrowers of the cosmos. They can span 1,000,000 light years. They paint the universe with fire. We are lucky to be out of range. But ranges change. The universe is dynamic. The flamethrower is swinging around.